Every single app you use today is secretly talking to dozens of other apps. Your weather app, your banking app, your favorite game, they all rely on one thing: APIs. And honestly, most developers still get them confused. There are way more types than you think. REST, GraphQL, WebSockets, gRPC. These are not the same thing at all. Today we are going to break down every major type of API in plain English. No fluff, no boring textbook definitions, just real explanations you can actually use. By the end of this video, you will know exactly which API to pick for your next project. Let's get into it. Okay, so before we jump into the types, let us get one thing straight. An API is just a contract between two pieces of software. That is literally it. You ask for something in a specific way and you get something back. Think of it like ordering food at a restaurant. You do not walk into the kitchen and cook yourself. You talk to the waiter talks to the kitchen and food appears. The waiter is the API. Now here is the twist that most people miss. APIs are not just for the web. They exist in your operating system, in hardware drivers, in mobile apps, everywhere. When you press the camera button on your phone, an API call happens. Every button click, every screen load, every notification, APIs are doing the heavy lifting. So yeah, they kind of matter a lot. Alright, REST APIs. These are the ones you have definitely heard of. REST stands for Representational State Transfer, but honestly just forget that name. What matters is how it works. You have URLs that represent resources, /users, /products, /orders, you get the idea. Then you use HTTP methods to interact with those resources. Get to read, post to create, put or patch to update, delete to remove. It is clean, it is simple, and that is exactly why it became so popular. REST APIs are stateless too, which means every request carries all the info the server needs. The server does not remember you from last time. Here is a quick real example. You want to get a list of users. You send a GET request to /API/users. The server sends back JSON, done. Super predictable, super readable.
Super high level tactic, remember that, yeah?
That is why REST is still the default choice for most web projects today. Now here is where things get interesting. GraphQL was created by Facebook back in 2012, and it completely flips the REST model on its head. With REST, the server decides what data you get. With GraphQL, you decide. You send a query saying exactly which fields you want, and you get back exactly those fields. Nothing more, nothing less. This solves a massive problem called overfetching. Imagine you only need a user's name and email, but the REST endpoint sends you 30 fields, including stuff you will never use. That is wasted bandwidth. GraphQL kills that waste. There is also underfetching, where REST makes you call 5 different endpoints to build one screen. GraphQL can do all of that in a single request. The catch though, GraphQL has a steeper learning curve, and caching is trickier because everything goes through one endpoint. So it is powerful, but it is not always the right tool. Okay, let's talk about SOAP. Simple Object Access Protocol. And I know what you are thinking. Nobody uses this anymore, right? Wrong. Banks use it, airlines use it, government systems run on it. SOAP is the dinosaur of APIs, but it is a very well-armored dinosaur. SOAP uses XML for everything. Requests are XML, responses are XML, error messages are XML. It is verbose, and it feels heavy compared to modern APIs, but here is why enterprises love it. SOAP has built-in standards for security, transactions, and error handling. It supports WS security, which is enterprise-grade stuff. It also has something called WSDL, a web services description language file. This file describes every single operation the API supports, like a contract written in stone. If you are building something that requires strict compliance, like financial transactions or healthcare data, SOAP might actually be the right call. Do not sleep on the dinosaur. Alright, now we are getting into the fun stuff. WebSocket. So, with REST and GraphQL, every interaction is request and response. You ask, the server answers, connection closes. That is fine for most things. But what about live chat? What about stock prices updating every millisecond? What about multiplayer games? You cannot refresh a REST endpoint 60 times per second? That would be insane. WebSockets solve this by keeping the connection open. Once established, both the client and the server can send messages to each other at any time, in real time. There is no more asking and waiting. The server just pushes data to you the moment something changes. This is called full duplex communication. Think of it like a phone call versus sending letters. REST is sending letters. WebSockets is a phone call. The connection stays open, and both sides can talk whenever they want. This is why every live app you love uses WebSockets under the hood. This one is a favorite of mine. gRPC was built by Google, and it is designed for one thing: speed. gRPC uses protocol buffers instead of JSON. Protocol buffers are a binary format, meaning the data is much smaller and way faster to serialize than text-based JSON. We are talking up to 10 times faster in some benchmarks. gRPC uses HTTP2 under the hood, which means it supports multiplexing. Multiple requests over a single connection at the same time. It also supports streaming. You can have the client stream data, the server stream data, or both streaming at once. This is called bidirectional streaming, and it is incredibly powerful for things like real-time data pipelines. The downside is that gRPC is harder to debug because binary data is not human readable, and it is not great for browser-to-server communication directly, but for microservices talking to each other inside a backend system, gRPC is often the best choice on the table. Here is a concept that trips up a lot of junior developers: webhooks. Imagine you order a package online. You could refresh the tracking page every 5 minutes, checking if it arrived. That is polling. Or you could just get a text message when it actually arrives. That is a webhook. With webhooks, instead of you calling the server calls you. You register a URL on your end, and whenever something happens, a payment is completed, a new user signs up, a file is uploaded, the external service sends a post request to your URL with the event data. Stripe uses webhooks heavily for payment events. GitHub uses them to trigger builds. They are event-driven and super efficient. The tricky part is that your server needs to be publicly accessible to receive them, and you need to handle failures because sometimes the webhook delivery fails and you need to retry it. Always verify the webhook signature too. Security matters. Okay, so we touched on streaming with gRPC, but let us go deeper. Streaming APIs are for situations where data is continuous and never really ends. Think Twitter's firehose, every tweet sent by every user in real time. You cannot request that as one big response. It would crash everything. Instead, the connection opens and data just keeps flowing as events happen. Server-sent events is a simpler version of this. The server pushes updates to the client over a one-way HTTP connection. It is lighter than WebSockets and perfect for dashboards, live feeds, and notifications. Then there is the full streaming model used by services like Kafka or Cloud Pub subsystems. These handle massive volumes of event data across distributed systems. The key difference from WebSockets is that streaming APIs are usually one direction, optimized for high volume data. They are designed to handle millions of events per second reliably. If you are building analytics or monitoring tools, this is your territory. Here is the thing most people forget when talking about APIs. We have been talking about network APIs, but APIs exist in way more places than the internet. Every programming language has a standard library full of APIs. When you call Python's open function to read a file, that is an API. When you use the JavaScript date object, that is an API. These are language level APIs baked right into the tools you use. Then there are operating system APIs. When your app wants to read from disk, access memory, or open a network socket, it calls OS APIs. On Windows, these are Win32 API calls. On Linux, it is system calls into the kernel. You rarely call these directly in modern development, but frameworks call them for you constantly, and hardware APIs let software talk to GPUs, cameras, microphones, and sensors. OpenGL is an API for the GPU. The Web Audio API lets browsers access your microphone. APIs go all the way down to the metal. They are everywhere. Alright, so now you know all the types. But which one do you actually pick? Here is a simple framework. If you are building a standard web or mobile app with CRUD operations, go with REST. It is simple, well documented, and everyone on your team will understand it. If your clients need flexible queries, and your data is complex and nested, consider GraphQL. It shines for product catalogs, social feeds, and dashboards. If you need real-time communication, like chat, games, or live collaboration, use WebSockets. If your backend microservices need to talk to each other at high speed, use gRPC. If you need to react to events from external services, like payments or code pushes, use webhooks. If you are dealing with massive continuous data streams, think streaming APIs or pub subsystems. And if you are integrating with a legacy enterprise system, you might be stuck with SOAP whether you like it or not. No single type wins everything. The right tool depends entirely on the job. So there you have it. REST, GraphQL, SOAP, WebSockets, gRPC, webhooks, streaming APIs, library APIs, and OS APIs. These are the building blocks that power literally everything in software today. The developers who understand these tools and know when to use which one, those are the developers who build systems that actually scale. If this video helped you out, drop a like and subscribe because we go deep on stuff like this every week. Got questions or want me to cover one of these in a full dedicated video? Drop it in the comments right now. I read every single one. See you in the next one.